a signal from a planet in outer space that rejects all norms and a race to. What if we had another star? What we believe to be true about the cosmos is. James Webb is on the verge of breaking. The Space Telescope JWST has revealed disturbing truths that they might have mend the guidelines for life in general. But can Proxima really be a lethal trap in the new Earth? The James Webb Space Telescope and the immensity of it. Many people regard the telescope as humanity's the most sophisticated in the sky has just looked in the direction of one of the most fascinating exoplanets ever found. This far-off planet is circling Proxima B. Proxima Centauri, a red dwarf star, possesses interested researchers and fans similar to that of its discovery, but now with the unmatched potential of the at last we're getting close. Examine this enigmatic planet and the disclosures are nothing less than remarkable. Proxima B was initially discovered in 2013, but not until when the James Webb Space Telescope entered the image that we may really enjoy what's on this far-off planet. Though the capacity of a telescope to record infrared pictures have made it possible for astronomers to look entering the atmosphere of Proxima B, exposing information that was previously concealed from observing. What they discovered has inspired both concern and exhilaration. When you see Proxima B revolves around its star at a very tight to 7.3 million kilometers distant, which is less than 5% of the separation between Earth and the Sun, are so close, indicates that the planet has finished to complete orbit in just 11.2 days on Earth. But what's even more intriguing is that the star it orbits, Proxima Centauri, is a red dwarf in contrast to the Sun, which is a red dwarf. Stars that are comparatively stable are renowned for being erratic, often releasing strong solar flares that are capable of significantly alter the planet's orbits. Now here is when things get even more intriguing than what the JWST has offered. Proxima B's sharpest photograph to date, and some surprising aspects have been uncovered. The globe is around 30% more larger than Earth, indicating that it has a more gravitational attraction. But what is really startling is the potential that tidally locked is Proxima B with its, indicating that one side of the globe is always in sunshine, yet the second is covered in eternal darkness. Picture the kind of environment in which on one side the sun never sets and the other is thrown into a tidal locking produces a severe surroundings for any possible living creatures. The side that faces the star is burned by continuous radiation exposure, while a frozen wasteland would be the bad side. This poses an important query: does life ever survive in such harsh circumstances? The likelihood seems to be low. However, we are often surprised by nature. However, the difficulties don't end there by alone. Proxima Centauri offers a substantial risk to the habitability, according to JWST Proxima B, indicating the star's activity is far higher than previously believed to have strong magnetic output. Strong solar flares are produced by fields that blast Proxima B with a lot of energy radiation. Really, a flare that was seen in the power in April 2021 was 100 times greater than any flare our sun has ever produced. Such a huge energy explosion may eliminate the atmosphere of the planet, leaving it vulnerable to the severity of space. Some scholars contend at Prox's nearness to its star and the regular solar flares reduce the likelihood of supporting for some. However, life as we know it imply that life may find a method to adjust to these harsh circumstances. Might Proxima B contains creatures that have developed to endure in unstable surroundings, or is the planet destined to stay a barren rock without life? As we investigate Proxima B furthermore with the James Webb Telescope, there will undoubtedly be secrets revealed, but one, it's obvious that this little planet, only for 0.24 light years, is a long distance from us, more intricate and mysterious than we Ever is it possible that Proxima reveals the secret to comprehending the boundaries of life in the cosmos, and what implications does it have for our quest for Proxima's alien life? Beautiful secret spotted. One of the most startling findings were the planet's atmosphere, or more specifically the possible absence of it. The extreme combined radiation from the Proxima Centauri because of the planet's tight orbit. Proxima B receives regular barges of high-energy particles and a solar wind. With time, this relentless attack may have taken away the Earth's atmosphere, making it exposed and barren to the icy void of space. Although this, when things start to become interesting, according to experts, Proxima B could maintain a thin atmosphere made up of heavier gases such as carbon, nitrogen, or carbon dioxide that might provide a little shielding from the stars. The James Webb Telescope's radiation provided us with the most clear glimpse so far. The surface of Proxima B and its characteristics disclosed as intriguing, and the planet's surface seems strange, should resemble Earth's rocky terrain, but with notable variations, such as the planet side that faces Proxima Centauri is probably burned by the heat all the time, creating a barren desert-like environment. Meanwhile, the planet's dark side, a frozen wasteland, maybe when the temperature drops to levels much colder than what was seen on Earth. But the most fascinating potential is found in the little area of the area in between these two extremes is referred to as this region is known as the Twilight Zone, or day. Meetings at night might provide more temperate circumstances under liquid water may exist. The liquid water's existence is naturally one of the essential components for this twilight life as we know it. Might Zone Harbor is a secret paradise where life exists, has succeeded in establishing itself in spite of the difficult circumstances for the remainder of the world. Yet another breathtaking revelation when researchers looked at the possibilities whether there is any water on Proxima. On Earth, it would probably be in the shape of dark side ice or tiny, potentially transient liquid bodies. The Twilight Zone's water, but the many were startled to learn that the possibility of comparable subterranean seas to those who reside on moons such as Europa or in our own solar system Enceladus. The planet's heat might warm the waters, either by tie forces brought on by Proxima B's near orbit around its star. If any there are seas, they would be a perfect example where to look for hidden life under the cold surface of the planet. Although remembering the potential contest Proxima's magnetic field, another element that contributes is the center intricacy of the environment on Earth. According to current research, the star's magnetic field could engage in interactions with the Earth's core, producing its own magnetic field. This interaction might shield the atmosphere of the planet from being totally cut off from solar breeze that resembles the magnetic field of Earth shields us from the rays of the sun. But the circumstances on Proxima, the stars, are far from simple. Strong flares might overpower the planet's magnetic barriers, which result in abrupt and significant changes in the climate and surface conditions of the planet. These findings raise further questions then responds to whether Proxima B has a how powerful is the magnetic field, and how does it have an impact on Earth's environment and the possibility of life. Proxima B's life has changed to endure the planet's severe and changing circumstances, and if life does exist, what shape would it take? Be quite distinct from something that we have seen on Earth, or may it have traits in common with extremophiles that flourish in the most hostile environments on Earth conditions? In a harsh planet where life encounters many obstacles, when the concept imagine a planet around Proxima that is livable center is enthralling, but it's far from genuine. From the welcoming James Webb Space the telescope has offered hitherto unheard of understanding of the difficulties any possible life on the face of Proxima, and the image is not at all rosy. One of the biggest obstacles is the planet's exposure to high Concentrations of Proxima Centauri. Radiation is different from our red dwarf star is the Sun's Proxima Centauri, having a much lower mass and a far more turbulent surface that this star is close to. According to Proxima B, the planet is continuous barrage of powerful solar radiation, such a strong flare as that may be a 100 times more powerful than these flares that our sun emits, create a lethal combination of UV and radiation from X-rays that would be fatal to any kind of life that resembles that found on Earth. This radiation's effects are not merely hypothetical. In April 2021, very large flare from the Proxima Centauri was found, and it was potent, sufficient to perhaps remove any atmosphere that may have been present on this incident. Act as a strong reminder of Proxima B, reminder of the risk that red dwarf stars, and raises questions about the probability that Proxima will serve as a haven for life. In addition to the ongoing exposure the surface would be exposed to such radiation, a Proxima B quite antagonistic surroundings. Any surface water would quickly evaporate, and the rocky terrain of the planet would be the darkness was burnt by the unrelenting heat side of the Earth. Without being exposed to direct radiation would be just as uninhabitable, because to the cold temperatures this star contrast among the blazing day side in the little space is left by a frozen night's side for a steady environment that supports life. The race to get to Proxima starts while the Proxima Centauri signal is yet unknown. The concept of actually the star system has shifted from science fiction's world to a sincere scientific endeavors. The groundbreaking Star Shop project, led by a group of inspirational scientists and supported by well-known individuals such as Yuri and Stephen Hawking Milner, wants to launch small lasers that the Alpha Centauri system's spacecraft Proxima Centauri is included in our lifetimes. The idea that the goal of the breakout Starship shot is as lofty as the proposal is groundbreaking, since it includes placing hundreds of small spacecraft into orbit. Each one is around the size of a stamp. These star chips would be sent into space outfitted with cameras for communication tools and sensors to collect information such they set out to find the closest star system. But this mission's unique. The propulsion is quite revolutionary mechanism of strong ground-based lasers that would speed up these little satellites to an astounding 20% of the speed of light. At this astounding velocity, Proximus might be reached using the star chip Centauri in a span of slightly over 2 decades at cosmic eye, and once there they would send information back to Earth, providing our first close-up view of Proxima B as well as the other alpha planets. The technology behind this is the Centauri system. Although the expedition is still in its early phases, the advancements so far have been nothing less than extraordinary. Difficulties of the objective and the consequences for the future, and the notion of getting to another star has enthralled us throughout our lives, both the public and scientists, but it also poses important difficulties, one of which is one of the largest obstacles is the absolute quantity of energy needed to move, taking this spacecraft so fast that this mission lasers would need around 100 gauss of electricity, equal to the whole electrical production of the United States. That this energy would have at any time should be focused into an exact beam directed at the little spaceships, speeding them up over a duration of minutes before they accomplish their goal velocity. Another significant obstacle is that the spaceship itself is moving at 20% of light speed, implies that even small particles in space may result in terrible harm to the star chips. To reduce this danger, the spaceship must be outfitted with cutting-edge shielding, and their course need to be meticulously planned to steer clear of places of area where dust concentrations are high or debris. In addition, the star chips must be resilient enough to endure the harsh produced heat from the lasers and the harsh space conditions, but maybe The most fascinating problem is what occurs when the spaceship arrives at where the signal was returned to from. Proxima Centauri Earth will take more than 4 years to reach, indicating that even after the completion of the star chips, the journey will take a few more years till we find out whether the operation was a success, as well as whether or not we get data what might be revealed from Proxima B. Will finally we look for unambiguous proof of an planet that resembles Earth, or may we find something completely unexpected? The consequences of arriving in Proxima Centauri are significant. If this mission is successful, may open the door for future possible interstellar travel, enabling our exploration of additional star systems. Could perhaps uncover uncharted territories that may encourage life, but the goal also increases philosophical and ethical issues that if we discover proof of life, whether we are smart or not, how should we react, and what would happen if we arrived in an additional star system is thought to be a danger, as a breakout celebrity keeps improving the race to get to the Proxima Centauri is warming up. Potential for investigating a different star system isn't just a fantasy anymore, it's taking shape as the star chips. One aspect of getting ready for their journey is the race to Proxima Centauri is unquestionably just getting started, in the findings waiting for us might make all the difference. We are aware that our universe may be Proxima, the secret to finding life beyond. Is it Earth, or simply another cosmic intrigue? Fresh perspectives and unexplored potentialities. Yet a large portion of the emphasis on the focus of Proxima is its potential. There is still a lot of habitable unknowns about this planet that could take years or even decades before we really comprehend what's there. Though without a doubt, James Webb Space Telescope has made significant progress, but it's only one instrument in a far bigger cosmic. Looking at other telescopes in space, theoretical models and missions will be vital for assembling the whole. Proxima B's image shows promise. Research avenues include examining the planet's geophysical characteristics. For example, physicists are especially curious about the planet's interior structure that is mostly unknown. Given that Proxima B has a greater mass, greater than Earth, implies that it may possess a stronger, or maybe even producing its own. Such a magnetic field might be used to as an essential shield defending the planet from the fierce solar system. Nevertheless, flares as the magnetic field of the Proxima Centauri itself is quite unpredictable and dynamic. Uncertain whether Proxima B may produce a field powerful enough to provide enduring defense against another blast of cosmic radiation, a factor that makes it harder for us to grasp. Its probable composition is Proxima B. Its plan considered its Earth-like bulk. Conceivable that Proxima B is rocky, having a terrain that comprises enormous, vast plains, high mountains or valleys, but without being aware of the precise chemical composition of the planet is unable to determine with certainty whether its silicate minerals make up the crust metals or a mix of them. Enhancing the interest is the potentiality that Proxima B could possess tectonic activity. Was seen at some period in its history that resulted in a varied and the tectonic plates dynamic surface have changed over thousands of years, which may have helped to create characteristics of the Earth's surface, oceanic troughs or mountain ranges. If these procedures continue to occur today, it can make things even more difficult for assessing the habitability of the planet. The possibility of subsurface oceans also provide intriguing queries. If there is liquid water below the surface of Proxima B was protected from the severe surface circumstances, it makes the potential for an ecosystem to flourish in these depths that resemble the living forms discovered in the hydrothermal deep seas of Earth. Common vents seen on the ocean floors of Earth may provide the energy required for such ecosystems to endure in their entirety, ultimately being cut off from the Sun. While Proxima B's Conditions might seem unwilling to support human life that doesn't eliminate the chance of microbiological organisms that survive under harsh Earth's extremophile ecosystems, creatures that can survive in harsh radiation or heat acidity imply that there may be areas where life exists at one point. We believe that the hunt for responses go on while Prox is a remote location poses significant logistical difficulties that it also provides humanity's once-in-a-lifetime opportunity chance to discover a new planet, whether there is life on the planet or if it is just another barren rock that we investigated. It will provide us with insightful knowledge about the boundaries of existence and the enormous possibilities of the cosmos outside of our own the solar system.